So today I'm going to show you guys how to use our new Acuity TQD triple quadruple detector instrument. There's some new features in MassLynx 4.1, in particular the MS console and intellistart that we need to cover that are slightly different from other instruments that we use in the lab. So to access the MS console, you just select MS console over under the instrument page in MassLynx. Right. So when you open up the MS console page here, what you see are the parameters that you have the MS set to up in the top left-hand corner here, and on the right-hand side, the main instrument controls. So you can turn the instrument on from standby, turn on your API or collision gas, and also access the tune page. As you can see, in real time, we're updating the tick, analyzer vacuum, source temperature, and a variety of other instrumental parameters that we can monitor. If I open this page, or expand this page, what I see is the intellistart menu. So on the intellistart page, we have a variety of setup options that we can choose from. One of the first things you might want to do is set up the resolution of the instrument and have it automatically tune the instrument for you, as well as calibrate the instrument. So in order to do that, we open up the setup options here, and we select instrument resolution. Now we can have it optimize the resolution for positive or negative mode or both. And in this case, we're going to do both. So in reservoir A right now we have a solution of sodium iodide and cesium iodide that we can use to do this resolution check. So once I have these selected, I can press start over here. And I open up this window, which gives me a variety of options of how I want to do this resolution and calibration. So we can just ask it to do a high mass resolution, giving us nice peak shape, low mass resolution, giving us poor peak shape but high sensitivity. Quantitative is for very, very, very low concentration analyses, and unit mass resolution is somewhere in the middle of low mass and high mass resolution. When I select unit mass resolution, what it opens up here is a default setup range target resolution. So it asks what kind of positive reference I'm using, and of course, as I said, we're using sodium iodide and cesium, as well as sodium iodide for the negative ion mode calibration. So it'll walk through these two reference files when we're doing our resolution optimization. You can select the mass range that you want to calibrate in. Default is 2 Daltons to 2048 Daltons, but I can select a custom range if I want to optimize a particular range, but in this case we'll just leave it at default.
So why is it that this one will go as low as 2 mass units and not stop at 50?
I actually don't know, to be totally honest.
Because, I mean, we can't detect 2 on this thing, right?
Theoretically, we can.
Really?
Yeah, I mean, you can pick up sodium, 23. I haven't tried anything at 2 yet. But my guess as to why you can do that versus on the top, my guess is that the quadruple can handle lighter mass ions.
Okay.
So it can create effectively a stable ion beam out of low mass ions, whereas the top presumably can't handle that for some reason. Maybe it can't apply a lower amount of energy to low mass ions, I'm not sure.
Okay.
But one suggestion, one thing that I would be careful of is that if we're looking at really low mass ions, because the vacuum levels in this instrument are lower, the mean free path is smaller, and despite the fact that it is a short range that it has to go through from quad 1 to quad 2 to quad 3 to the detector, small weight ions might not survive that journey and might break up into other things or dissipate into the collision cell or something like that. So you might not pick up things like that anyway. Also on this page, underneath the mass range, is the calibration speed. So the default is fine here. Effectively, at its slowest, it'll be running at 100 Daltons a second. At its fastest, it'll be going at 10,000 Daltons per second. And that's just to optimize the scanning speed, because it may vary depending on what your mass range is and what your scan time is. So here, when we select our unit mass resolution, it's selected a unit mass, which is about 0.75 resolution in terms of Daltons. We can change that if we want to a lower resolution, so a wider, fatter peak, or a higher resolution if we're looking for better isotopes patterns. Under fluidics here, we want to select our sodium iodide cesium solution, which happens to be under reservoir A. When you select that, it'll automatically purge the fluidic system with that reservoir and start injection once I click start. So if I have something that I've changed up here that I want to save for later on, I can click save and recall that method later on. For now though, we can just click start and it will automatically start tuning the instrument. So at this stage, it's either going to purge the fluidic systems if it hasn't done that already. Otherwise, it's going to wait for the system to reach optimal conditions. Those optimal conditions you can see on the tune page, or you can also see them on the MS display here. So it's reaching what it needs to do this resolution verification, which is 500 liters per hour flow rates, 250 degrees Celsius desolvation gas, 3 kV capillary, 30 volts cone voltage, 150 degree source, and so on. You can read all those off of here. Now that it's reached the initial conditions, it's going to start walking through the different stages of MS, optimize the cone voltage, and so on and so forth, until it's acquired what it sees as the optimal resolution for sodium iodide and cesium. Now that the intellistart program has run through the instrument resolution setup, we can see there's a success, a check mark, and when you do that, or when you get that, you can get a printout here on the desktop telling you with what parameters it passed these checks. So, for example, with MS1, we passed the positive ion mode resolution check, and it's left us with a final tube page setting that we can read off here. And that will be saved to the current IPR file. From there, we can go ahead and ask it to do a calibration. Now that our instrument resolution is optimized, all we do is we check the instrument calibration setup and click start. Once we do that, we have a default setting that we've already applied doing the instrument resolution. We can just click start and it will start running through the calibration. So again, we'll have to wait for the instrument to reach initial conditions. It'll purge the system depending on what reservoir is being used and start to infuse sodium iodide again to perform the instrument calibration.